Local arena has 10 applicants working in the snack bar, and they want to choose 4 people to work there. Does the order matter? This is the question that you're going to now have to start asking when you hit any permutation or combination question. Because they start off with a similar question. How many? Because it's a counting question. So your first thing you have to decide, does the order matter or does the order not matter? If I hire 4 people, but I hired Frank first, does that make a difference? No. They're still hired no matter what. It would make a difference if all of a sudden whoever's hired first, you're getting paid $800 an hour. Whoever's hired second gets paid $200 an hour. Whoever's hired third gets minimum wage. And whoever hired fourth gets 15 cents an hour. Then it would make a difference. Because if you were hired fourth and you're doing the same job as Frank and he's getting $800 an hour and you're getting 15 cents an hour, that causes some tension at work. I don't know if you've ever been at work where you're doing the same job as somebody else and they're getting paid more. It's not good, right? Yeah. But in this case, everybody's going to get paid the same, so the order doesn't matter. As soon as the order doesn't matter, this just becomes 10 choose 4. You can put that into your calculator. Knowing the formula is 10 factorial. There will be a 4 factorial. What will the other number be on the bottom? 6 factorial. The bottom 2 numbers always add up to the top one. So then does it make sense that in B, if they decided, no, instead of 4 people, we need to hire 6 people? By the way, what is 10 choose 4 on our calculator? 210? Perfect. All of a sudden they say, no, let's hire 6 people. 10 choose 6. Well, this would be 10 factorial, 6 factorial. What would be the other number? 4 factorial. It's also 210. And so they want us to notice that choosing 4 from 10 is the same as choosing 6 from 10. Because if you have 10 different, so if I take out 10 different cards here, right? Every time that I choose 4 cards, I'm left with 6. So every unique group of 4 leaves me with a unique group of 6. And since the order doesn't matter within these groups, choosing 4 from 10 is the same as choosing 6 from 10. And so this concept often comes up in homework questions where they say, you know, what's R? If 12 choose R is equal to 12 choose R plus 2, what's R? Well, obviously these 2 numbers are different, right? Because one's R and one's R plus 2. So one's 2 bigger than the other number. But what do we know about these 2? If they're going to be equal, what do we know about those 2 numbers? If I'm choosing a group of 4 and it's the same as a group of 6, how many numbers did I start with? I started with 10. So if I'm choosing a group of R and I'm choosing a group of R plus 2 and I started with 12, that's telling me that 12 has to equal R plus 2. And in this case, if you solve for R, you get R equals 5. Does it make sense that choosing 5 is the same as choosing 7 from 12? Yes. So we do get this idea creeping into questions, but not directly. All right, questions you can do for practice on this one. Are 8 and 10.